type them into the text box. Okay, so let us start chapter 10, Radical Expressions and Equations. So, section 10.1, Finding Roots. So, the square root of 16 is equal to 4 because 4 squared is 16. Okay. If I don't put a number here, let's assume that the number is 2. And so 4 raised to the power 2 is 16. Therefore, the square root of 16 is 4. Next, the cube root of 8 is equal to 2 because 2 cubed is 8. So, the number here, which is very small, is called the index. This symbol here is called the radical symbol. This number inside the radical is called the radicand. Okay, so let me give you the concept of a principal nth root. If n is even, and if a is greater than or equal to 0, then the principal nth root of a is the non-negative number b, so b is greater than or equal to 0, such that b to the n is a, such as what we've done above. And so the nth root here, the square root of 16, is 4. And so the principal nth root of a is 4. The non-negative radicand 16 has a principal square root of 4, 4 being a non-negative number, since 4 to the power 2 is 16. If n is odd, then the principal nth root is the real number b, such that b to the n is a. So in this case, for odd indices, I do not have to specify that the radicand is non-negative. So I can take odd roots of negative numbers. But I have yet to define the even root of a negative number. So we denote the value of b by the nth root of a. And so that's just explaining this above for all cases. So note, we have not defined the principal nth root of a when n is even and a is less than 0. We will in the future, towards the end of this chapter, I think section 10.6, we will define what that means, but at this moment, I have not defined the even root of a negative number. So let's do on page 407, problem number 4. In exercises 1 through 16, find the principal square root of the number 225. So the principal square root of 225 is, well, that non-negative number such that its square is 225. Well, 15 squared is 225. Therefore, the square root of 225 is 15. So notice that this symbol here indicates a principal square root. And so there's only one answer. The one answer for the principal square root of 225 is the positive number 15. Let's do problem number 16. The square root, the principal square root of 144 divided by 169. And so the square root of 144 is 12, because 12 squared is 144. The square root of 169 is 13, because 13 squared is 169. Therefore, the principal square root of 144 over 169 is 12 over 13. Any questions about that? Okay. Let me do problem number 20. In exercises 17 through 36, find the indicated roots, if possible. I want to find the sixth roots of 64. And so the radicand is 64, and the index in this case is 6. So I want to find a number such that when I raise it to the power 6, I get the number 64. And since 6 is an even number, then I want the non-negative number whose value when raised to the 6th power is 64. Well, 2 times 2 times 2 times 2 times 2 times 2 is 64. 2 times 2, 4, times 2, 8, times 2, 16, times 2, 32, times 2, 64 is indeed 6. 2 to the power 6 is indeed equal to 64. Therefore, the sixth root, the principal sixth root of 64 is 2. Let me do problem number 28. I want to find the sixth root of a negative 64. Well, since 6 is an even index, and since the radicand, negative 64, is not non-negative, it is negative, then I have not defined the even root of a negative number. Since I've not defined the even root of a negative number, then I say that, well, this is just not defined. Maybe in the future, like at the end of this week, we'll know, but at this particular moment, I do not know. I've yet to define the sixth root of negative 64. Let me do problem number 36. I want to find the sixth root of 64 over 729. Well, the sixth root of 64 is 2. The principal sixth root of 64 is 2, because 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So 2 to the power 6 is 64. Therefore, the sixth root of 64 is 2. Next, let's determine the sixth root of 729. 3. 3 times 3, 9, times 3, 27, times 3, 81, times 3, 243, times 3, 729. Therefore, 3 to the power 6 is 729. And so the sixth root, the principal sixth root of 729 is 3. So therefore, the principal sixth root of 64 over 729 is 2/3. Let me do problem number 44. In exercises 37 through 50, find the value of the radical. The cube root of 64. And so I want to find a number such that when it's raised to the power 3, I get 64. Well, 4. 4 times 4, 16 times 4, 64. And so 4 cubed is 64. Therefore, the principal cube root of 64 is 4. Problem number 50. The fourth root of negative 16. Well, again, we have an even index, 4, and we have a negative radicand. A even root of a negative radicand is not defined. And so the fourth root of negative 16 is not defined. Let me do problem number 56. In exercises 51 through 64, evaluate the expression. The square root of 13 squared. Well, the square root of 13 squared is 13 because 13 is such that its square is a radicand. And so the square root of 13 squared is 13. We can think that the square gets rid of the square root. And so if you raise a radical to the same power as the index, the radical disappears. Not exactly true. We have to worry about signs and other things, but more or less. We can more or less say that, well, this is a true statement, that the if you look at the root of some quantity, then the power to the same index is the inverse function of that radical. So radicals and powers are inverse functions of each other. The nth power of the nth root are inverse functions of each other. Of course, assuming that it's 1-to-1. Otherwise, you have to make a little bit of, well, make sure it's 1-to-1. And that's why we have the principal nth root. So it makes it 1-to-1. Next, problem 52. The square root of negative 17 squared. Well, the square root of negative 17 is not defined, therefore its square is not defined. We have yet to define the even root of a negative number, and so the square of a quantity that is undefined is still undefined. Let me do problem number 64. The negative cube root x cubed plus x over 8, all quantity cubed. Well, a negative number cubed is negative. The cube gets rid of the cube root, and so what remains is just a radicand, x cubed plus x over 8. Any questions about that? Okay. Next. If you have, so let me do problem 66. If you have a root of some quantity, and if that quantity is a perfect nth power, then the nth root of the nth power will be rational. The nth root of, well, let's say that the radicand is a rational number to an nth power, so it's a perfect nth power. Then the nth root of this perfect nth power is rational. If the radicand is not a perfect nth power, then the answer will be irrational. If you try to take an even root of a negative number, then that quantity will be a non-real answer. In exercises 65 through 74, identify the numbers as rational, irrational, or non-real. So I want to determine if the cube root of 27 is rational, irrational, or non-real. Well, 27 is a perfect cube. The perfect cubes, I'll just look at the positive perfect cubes, are 1 cubed is 1, 8, 2 cubed is 8, 27, 64, etc. And so those are perfect cubes. If I tried to a cube root of something that wasn't one of those, then it would be irrational. But the cube root of 27 is rational because 27 is a perfect cube. Let me do problem number 68. The cube root of 18. Well, the cube root of 18 is irrational because it's not a perfect cube. The only perfect cubes were, the positive. Let's look at the positive perfect cubes and whole number perfect cubes. Well, natural number perfect cubes. It would be 1, 8, 27, and so 18 is not one of them. Therefore, the cube root of 18 is irrational. 70. Square root of negative 36. So in this case, we have an even index, but the radicand is negative. The square root of a negative 36 is therefore not a real number. It will be something else, what we call the complex number, later on in this chapter. But it's not real. Negative square root of 25. Well, the 25 is a perfect square. Therefore, the square root of 25 is rational. Therefore, the negative of that rational number will still be rational. And so negative radical 25 is a rational number. So notice that if the negative were inside the square root, it would not be a real number. But if this negative is on the outside, in these particular cases, they would be rational. Okay, so that finishes off section 10.1. Any questions about section